Hello world, this is Craig. If you've been watching my videos, you know that I just finished building this MIL Mod 8 system, which is based on the Intel 8008, and I also have the cards to operate this on the Intel 8080. Before this system, I hadn't really had the opportunity to write 8008 assembly code on a real piece of hardware. And since I finished this, I've written quite a bit of code for the 8008, but for the most part, the code that I'm running on this, I've ported over from my 8080 systems. Going from the 8080 down to the 8008, porting is a fairly generous use of the term because it's pretty much a rewrite of the code. There are so many features in the 8008 that are missing compared to what we've just become accustomed to in the 8080. So I developed some guidelines for myself when I'm porting code over. I try to follow these guidelines, and it's made my porting projects easier. So I thought I would share those with anyone else that's interested in the 8008 processor and porting code over to it. The first one isn't the most important of the tips, and you may think differently, but I treat the registers as pairs in the 8008, even though they don't actually exist as pairs. There's no commands that let you do anything with pairs. You can't increment, you can't load registers as pairs or anything like that. But because of the HL register set, which is the high and low address of the memory pointer, because that's kind of treated as a pair, I also treat the other registers, the B, C, and D, E, as register pairs. Simply because I do lots of moving around of the HL register pair, and it's handier to put that in other registers that are also being treated as a pair. So just in general, I think of the registers as pairs, and I keep them together. So if I'm going to do anything with the register pair, I will use BC or DE rather than just CD, for example. It doesn't take any more work. I just treat them as register pairs. It also simplifies pointer management if it's possible to keep all of your buffers on the same page. This includes buffers that you're using in RAM and also things like lookup tables or text. And the reason it makes it simpler is if it's in the same page when you're using the HL register pair, you don't have to worry about the H. Being on the same page means that H doesn't change during the access of that. So you can set up H, and then you can just go through L and increment those. If you don't know where the memory page breaks are, then every time that you do an increment in L, you have to go back and see if you have to increment H also. To make my code more generic, write routines that are able to increment HL as if they are a pair, and it operates correctly across the page boundary. But for simplicity, it's easier to just keep things in one page, and it also makes the code a little bit smaller and tighter. Now, when rewriting code from the 8080 over to the 8008, probably the biggest lesson I had to learn was be consistent in sacrificing registers. With the 8080, you can program yourself into a corner where you found that you suddenly are short of registers, but it's easy to just push something out of the way and pop it back later. With the 8008, it's not nearly as easy to get yourself out of these corners that you've painted yourself into. And quite often I found I had to unroll a bunch of previous code in order to get back a register that I had destroyed previously. I came up with my rules for sacrificing registers, and these are my rules. And so this list of sacrificing registers is from the most precious to the least precious. I consider the accumulator to be the most precious if I'm using it for a subroutine where the value that is in the accumulator is likely to be useful after I come back from that subroutine. So for example, if I'm doing something like outputting to the serial port or teletype, where I put something in the accumulator, I then call that subroutine to do the output. But when that routine returns, I'm quite likely going to want to do something more with that value that's in the accumulator. In those cases, I will go to great lengths to save the accumulator at the expense of other registers. Whether or not I save A is either the most disposable register or it's the most sacred of the registers, depending on how that subroutine is going to act on it and what are the chances of wanting that register back intact after that subroutine returns. So A is actually on both ends of the list. The next registers that I'm unlikely to sacrifice are the HL register set. That's because HL is used for all of memory addressing. That's the only way that you get to memory on the 8008 is through the HL register pair. And it's quite likely that whatever you're doing in the program is going to require the use of that memory and the use of the HL pair. Of the HL pair, I'll sacrifice H before I sacrifice L because if I've been careful with my page breaks, chances are H is easy to restore. It's not changing all that much, so I can easily restore H from a load immediate. L is probably changing more frequently. So the HL pair are the least likely to be sacrificed, and of those, if I have to, I'll sacrifice H before I sacrifice L. Next down are the DE pair, and again, just like the HL set, I will sacrifice D before I sacrifice E. Finally, BC, and of those I will sacrifice B before C, so B is the guy that always gets it. B is like the red shirt in Star Trek. You can be pretty sure when you go into a routine or something, B is not coming back. Basically, my overall sacrifice order, in order from trash to keep, are the accumulator, and then registers B, C, D, E, H, L, and the accumulator again, depending on how I'm using that. So I make a conscious effort when I'm rewriting the code to sacrifice registers in that order. I also create and I follow a means of tracking what is where. And for example, if I have a subroutine that I've created called exchange, I'm going to call exchange. In my comments, I will say, okay, this is what is in each of these registers after this instruction. And for me, it just helps it keep clear as to what I've put where. Useful tip for any assembly, but it's really important with the 8008 when registers become all important and you can write yourself into a dead end really quickly. This all comes down to the main problem of the 8008 that I call register squeeze. And because we don't have the push and pop instructions, you can easily program yourself into a corner where you've run out of registers and you have to do something. And so I've been in many cases where I was writing some code and I found that I had just painted myself into a corner with registers, and I had to unroll some code ahead of that in order to get some registers back. One of the ways to deal with register squeeze is simply avoid the routines that are very destructive. So for example, character output is register destructive all the way around. You have to have bit counters, you have to have delay routines. So character output is very destructive. And to use character output like you would in the 8080, where you just have a character, you output it, you then have the next character, you output it, it's very destructive on registers. And so what I do when I'm working on the 8008 is rather than output character by character, I do a line output where I create a character buffer. And then all through this little portion of the code, I will just write things into that character buffer. And then when I need to output to the user, I will output that character buffer as the line rather than sending out individual characters one at a time. I've created a number of subroutines to utilize that character buffer. Here's a little subroutine called add DE, and this simply adds the contents of the DE register pair as ASCII to that character buffer. Like most of these things, to add to the character buffer, I have two versions. LADD, which locates and adds, and then I've just got the regular addDE, which just takes the existing value of the HL register set as the next location in the character buffer. Those for addDE. Also, I can add the HL pair, add a new line, add a space, add a tab, and so forth. A couple of other routines useful for the character buffer. There's one to just clear it, where it will go through and write a end of text in the character buffer, because rather than keep track of a counter in the character buffer, I use an end of text character to indicate when I've reached the end of that character buffer. So before I want to use it, I completely fill it with the ETX with the end of text character. Then I come back and I start filling it up, and then when I want to display that line, I just display it until I get to the end of text. And then when I'm to use that character buffer again, I clear it out and replace everything in it with that end of text. It's just simpler than keeping track of a pointer to have that end of text there. The other thing that allows me to do is concatenate to that character buffer. So I have versions here that allow me to take whatever pointer I have in the DE, and it will concatenate that to the existing character buffer. Like the others, I have two ways to run this. I can either do a cat string, which takes what's in the DE and what's in the HL and concatenates them together, or I can call the locate version of the cat string, which loads the HL pair with the existing character buffer. This is a really handy thing to use with the character buffer called the find the end of the scratch pad. The scratch pad's my character buffer. It's a very simple routine, but what it does is it goes out and it starts at the beginning of the character buffer and it just runs forward until it finds the first end of text. So that's the first address to continue the character buffer. Using the find end of scratch pad makes it so I don't have to worry about maintaining that HL register pair to point to the character buffer. I can lose that pointer to the character buffer and I can recreate it at any time. Finally, when I'm ready to send out that character buffer, I have the routine to send the string, which will start at the HL register pair and print out the rest of the character buffer until it gets to an end of text. Or more commonly, I use the version of that reloads the beginning of the character buffer into the HL pair. As soon as Intel released the assembler for the 8008, I think they realized that there were some register pair instructions that were missing and would have been nice to have, and so they actually wrote those in as macros in the original Intel assembler. Things like, I think, an LXI-H, for example. If you want to load the HL register pair directly from a memory location, that's a macro in the Intel 8008 assembly. What I've done is I have written a number of functions that mimic many of the instructions that are available in the 8080. So for example, I have written increment and decrement register pairs just as if they were valid instructions in the 8008. These instructions that are handy to have are the DAD, the double register add. So I have an instruction called DAD B, that's a double register add of BC in the HL pair. I have register pair decrements for the DE and the HL pair. I have register pair increments for DE and HL. I have LDAX, the PCHL, which sends the program counter to an address that's in the HL register pair. That's very, very handy. And I've written pop and push instructions for all of the registers. I then have something that's not a knockoff of a 8080 instruction, but I do have a register save and a register restore functions that will just go through and save all the registers and restore all the registers for those times that I've really written myself into a corner. Have the STAX, the set carry, and swap. Swap is a useful one that it takes whatever's in the HL register pair and it returns with the value that was at that memory location in the HL register pair. So it takes the pointer and converts that into the value that was at that pointer. And possibly the one that I use the most is an exchange that exchanges the DE and the HL register pairs. So these are all little instructions, just make it simpler to port things over. If I was incrementing a register pair in my 8080 code, makes it easier to do the exact same thing in the 8008 code. Plus, as Intel kind of acknowledged, there's a lot of register pair commands that are just missing in the 8008. The 8008 code will inevitably require more use of buffers than you were using in the 8080 code. As I already mentioned, if you can keep the buffers on the same memory page, it really simplifies HL addressing management. And because I'm using so many more buffers and I have to keep those straight, I set up the generic buffer to begin with, just as buffer 1, buffer 2, and so forth. But to keep them straight for that little portion of the code, I rename them at the beginning of that portion of the code using the set instruction. So then I can reference it as the purpose that it's being used in that little segment of the code. So that just helps a little bit in the bookkeeping. It just helps to make sure that you're using the register consistently. So finally, going back to saving registers. When I'm porting code over and rewriting it, when possible, I rewrite the code so I don't have to go to any great lengths to save registers. And for the most part, you can do that. You may have to go back and continually find more code that you have to rewrite. But if you do decide to save registers, there's a couple of different approaches to that. The first is to simply have a buffer that you use just for saving that register. And then you can do a load H immediate with the high portion of that address, load low immediate with the low portion of that buffer address, and then simply do a load memory from whatever register you want to save. It only requires 5 bytes of code and 1 byte for a buffer. And then to undo that, it just requires another 5 bytes of code. So for 10 bytes of code and 1 RAM buffer, you can save any register, and sometimes that's all that's needed. If you're going to save any registers at all, you have to accept the fact that it's going to cost you 2 registers. You're going to destroy 2 registers to save even 1 additional register. So this code, where we do a simple save of the accumulator, you can see we're going to destroy 2 registers. In this case, we have to destroy the HL. If we write a routine to simulate the push and pop instructions, we're going to do the same thing. We still have to destroy 2 registers. There's no way to save any register without at least destroying 2 registers. So in terms of the number of code bytes required, a subroutine that performs the equivalent of a double register push and a corresponding double register pop. So in other words, push the DE pair, pop the DE pair. That requires about 29 programming bytes, and then 2 RAM bytes for a buffer, plus whatever additional RAM you want to have for your simulated stack. So if you want to have a stack that can hold 20 things, you've got to have that 20 byte buffer for your 20 things. Because of the economy of scale, if you want to do a push and a pop of the accumulator and then the DE register pair and the HL register pair, to do those pushes, those 3 pushes and those 3 pops, you can write all of that code in 54 bytes. And I have to admit that when I've been porting code over from the 8080 and I'm in a push and I really don't want to do a whole bunch of rewriting of code, I will fall back and just use pushes and pops to save registers rather than rewriting a bunch of code and all the subroutines and all the subroutines that that code uses and all the subroutines that those subroutines use and so forth. Well, that's what I wanted to mention for porting code from the 8080 over to the 8008. I really enjoy programming in assembly, and I had a lot of fun writing new code in the 8008, but I also enjoy bringing code over and porting it over from my 8080 systems. And overall, I have just found that I have to be much more organized and I have to be consistent with a lot more things when programming on the 8008 than I had to on the 8080. In the 8080 and above, if you've programmed yourself into a corner, there's always a way to get out. In the 8008, it's just not that easy to recover if you've squeezed yourself out of all of your registers. All right, well, I hope you enjoyed that video. Thanks for watching, and if you have any questions, let me know. Bye-bye.